I'm going to start with the pre-webinar or pre-session discussion that we were having. I mean, I knew that you have a PhD in quantum chemistry. What happened? I mean, how did you end up running a GPU cloud company starting from your PhD in quantum chemistry? I mean, how can you tell us a little bit? I mean, how did this happen? How did you end up here?
Yeah, absolutely. Definitely wasn't my plan, right? I feel like I did a lot of soul searching when I was younger, and I decided to get into quantum chemistry because I thought it was just wicked cool, and it was, right? I did get to kind of play around with higher level math, and what I was doing was actually very much at the intersection of chemistry, physics, biology, mathematics. And so I got a chance to learn quite a lot and kind of just challenge myself, which was really awesome. However, as I was nearing completion of my PhD, I'm like, wow, while this is like really hard and really interesting and challenging for my brain, things move way too slow. So I ended up finishing it out because I didn't want to quit. Maybe I should have, but I finished it out and then thought about, okay, like, what do I want to do with this? And after a while, I did a stint teaching at a college level. And I was like, I really actually love two things. I love the collaboration and mentorship. And I also love to be challenged. But the career that I'm in right now offers me some of that, but not everything, right? I want to be able to move fast and break things, right? And that's not what's in it for my future if I stay with this. So I moved to software engineering because of that. Basically with the understanding that I just throw away like pretty much everything I'd learned, which on one hand was very sad, but on the other hand, I'm like, it's very exciting to get into a new field. Now that I'm actually doing things more in AI ML, specifically as associated with GPUs, I'm actually finding a lot of commonalities. When it boils down to it, a lot of this stuff is really just differential equations, right? It's minimalization problems, right? It's optimizing those. And I'm thinking, wow, like this is actually pretty close to what I was doing in graduate school if, applied to something completely different, right? So it's been kind of a full circle. And it's really exciting to kind of be able to experience that. As far as how I got into GPUs, I mean, it was really that as a software engineer, I was focused on scaling these large scale cloud systems. And I wanted to be a part of the individuals that built these things rather than the users, right, of all of these abstractions. And my co-founder and I were always looking at each other and saying, hey, like, how can we build these things, right? Rather than just using these things. Mm-hmm. All of it's kind of said and done in traditional cloud. Like there's not that much that we were super interested in. But as we were seeing AI ML workloads become more prevalent and popular and mainstream, we're like, wow, traditional cloud really isn't very well suited to deal with these things. So this is our chance. This is our wedge to get in there and really build some cool things that people will use and really help the next generation of software engineers.
Okay, thanks for the context here, Zen. So I think I will ask a very, very basic question that I have been in industry for quite some time, and just to give people an appreciation and understanding, right? So until maybe about 15-ish years ago, GPUs were meant to be, only gamers would actually get GPUs. Maybe in between there was the crypto folks, they were actually, using GPUs. So tell us, like how, why is there suddenly there is so much discussion and talk around the GPUs, right? So what is it that the GPUs can do that CPUs cannot? And why is NVIDIA valued at $1 trillion now, right? So why did this all happen, right? So when I was in grad school, we would use a CPU for, MATLAB and R for doing anything that you want to do. And now suddenly we are all about GPUs. So can you give us some context what happened?
Yeah, absolutely. There's a few parts to that question. Let's address like why now or why only recently, right? So it is in part what's happening with GPUs, but also in part like the bigger context. So let's say 2 decades ago, right? And honestly, like AI ML is the new hot thing, right? Quote unquote new, but it's been around for actually quite a long time. The things that have bottlenecked, right, our ability to really make advances in this is actually, and we're actually still bottlenecked on this, is the amount of data that you have available, right? So, as the internet has been growing, as companies, right, now have understood, like, look, actually being able to aggregate and store a lot of data just to have that data for later, right? They didn't actually know what they were going to do with it. But then we have these big data lakes that can fuel, right, the machine learning and to actually be able to train on. That's huge. And so we were kind of waiting for the ability for us to store this data in a performant way and then access it so that we can actually use it, right, for some of these things. But then you're like, okay, well, now I have the data, like, how do I actually process the data in any reasonable amount of time? And I feel like that's what really pushed us to go towards this idea of GPU computing. I think if I had to focus on one specific thing, it's that CPUs are focused on doing a set of linear tasks very, very quickly. And so there's this thing, right, called, they've got different levels of caching. They're generally fairly small caches, and it allows the CPU to swap things in and out of memory very quickly. That's really good for if you want to do a few things very quickly in a serial fashion. However, if you want to process, right, gigabytes, terabytes of data in a highly parallelized fashion, CPUs aren't very good at that. But GPUs are, because if you think about it, GPUs are originally made to render graphics, right? And if you think about how does a GPU render graphics, it has to do a lot of parallel computations to render every pixel on your screen. And it has to process an insane amount of data in order to do that. And so GPUs are really designed, right, when they're designed to make games, to be able to reduce the amount of bottlenecks to get the data to the actual processing unit as fast as possible. So the architecture that a GPU employs to actually facilitate this, if you look at a GPU's memory bus, it's much more robust than the CPU memory bus, right? So it's, okay, do we have the data we need to be able to do these things? No, okay, don't give up, right? Okay, now we have all the data. How do we like pipe it into something that can process this data as fast as humanly possible? And GPUs are just kind of the thing that we've started using for that. And in the last decade or so, right, now GPUs are becoming more and more specialized to do these things, right? We're creating things like tensor cores to be even better about it, right? We're having things like InfiniBand to allow us to even parallelize it even more. So, these are the advances that are really allowing us to kind of push the envelope on things like, OpenAI's GPT-4.
Okay, so has something fundamentally changed on the algorithm side that you would think that is making all of the GPU work possible? For instance, right? So neural networks have been around for a long time, right? And so we started using them and signed off, right? And the reason was, well, we don't have enough data. Even if you have enough data, we don't have the compute to process. So has anything changed on the algorithm side that actually is fueling all of this AI revolution that we see, right? All the large language models, you train them on GPUs. I mean, traditional CPUs cannot handle that kind of workload in a reasonable amount of time. So has there been any changes on the algorithm side, or AI and ML has remained pretty much the same? It is just something happening on the GPU or the enabling technology side.
Well, I feel like the thing that most people are gonna, say is transformers, right, and attention, right, is a big thing that's driven at least the qualitative properties, right, of the things that we're seeing, right. So with attention and transformers, I don't really think that we've done a lot around like how do we scale these things better. But what I think it did allow us to do is, OpenAI kind of made this like, hey, wow, we now have something that is qualitatively different than what we had before. And I believe what that did is it really lit a fire under people, and their passion and excitement is like, oh, wow, like we actually might be able to do something that we kind of gave up on, right? And so I believe that's really fueling now the search for how to scale these things better. things like MOE, right? And honestly, these are like not new ideas, but I just believe that there are now more people that are invested into like actually doing these things, putting a lot of money down, right? If you look at the training clusters that are used for these crazy models, like it's a lot of money and a lot of compute. So I don't necessarily think it's because we had a breakthrough in like, oh, we used to scale, n to the third, and now we can linearly scale, right? That I don't think that's the case. It's more like, oh, wow, this thing has the ability to change the world, right? And so let's throw millions or even billions of dollars at it. These things are not cheap, right? And so from an investment standpoint, the person actually bankrolling it needs to be like, okay, what is this going to get me? And if somebody's like, oh, I'm just going to train a bigger, CNN, they're going to be like, okay, yeah, no, I'm not going to give you that money to do that, right? So I think that's kind of where I'm at.
Okay. So is it fair to assume that, so you talked about attention mechanism or any of these algorithms? I mean, at the end of the day, I mean, it's a series of matrix operations, right? So, a lot of this is matrix algebra, right? So, and in theory, you could have implemented, I mean, barring any speed issues, how long it will take, you could actually implement these on a CPU. Am I correct here?
Yeah, you could, but it's just like a matter of when would I realistically be able to get results. And one thing that being more like in traditional software engineering, right? What I said earlier was one of the reasons I moved into software engineering was that I could reduce the time that it took me to iterate and see results. And I firmly believe that software engineers are probably some of the most impatient people in the world. And I don't think that that's like a novel thing, right? People want to see results in a reasonable amount of time. Nobody wants to say, I'm going to start this experiment and put down $100 million and then I'll see in a couple of years, right? Very few people are willing to wait that long. So in this case, yeah, I mean, I guess you could implement some of these things on CPUs, but it's just how long would it take you to actually be able to get results? And then would that be, with that result, like now you have a model, right? Would that be something that's actually even usable, right? Because at a certain point, things become qualitatively, not worth it, right? Because of the inference latency or the training latency.
Okay. Really, if the key takeaway would be is a lot of things they existed even previously. It is more the enabling technologies. Our storage became cheap. The transmission or transfer of data became cheaper, and then the compute became cheaper, and compute became faster, right? So, and that is what has fueled a lot of this revolution that we are seeing around us. So, tell us, why should an enterprise consider moving to a GPU cloud? Why should I, as a company, move to a GPU cloud, or what kind of workloads? Is it only for AI workloads, or are there any other workloads that I can offload on a GPU cloud? Is it all about AI?
I mean, it's not necessarily all about AI, although that's where the hype is, and honestly, that's where most of my interest lies, right? But there are a ton of other use cases that aren't necessarily around AI that uses GPUs. If you go back to actually my chemistry, right? You can do protein discovery, right? Do molecular dynamic simulations. You can even use GPUs to power some ab initio simulations for the finding the minima for electronic structure theory, which is actually what I did in my PhD. Then it may be something that people can relate more to is like, okay, well, a lot of creatives just need GPU powered desktops, right, for their day-to-days. And to be able to run the latest and greatest in a cloud environment actually makes a lot more sense than trying to stand up a ton of individual servers for an on-prem deployment. Because one thing that I am very appreciative of is, yes, you can think of GPU as just another part in a computer, but we are not very mature, right? It's not like CPUs where there have been decades of just iteration on how to run these things in the cloud and also on-prem, There's a lot of software to enable that and to make things easier. With GPUs, these things break all the time. They're incredibly hot. They're incredibly power hungry. You need to put in like special cooling, right? You need to put in special electrical, right, in order to actually run these things. That is an order of magnitude worse than if you were just going to run some CPU servers. So it really is just like, it's not easy to do these things. And so from an enterprise perspective, it makes a ton of more sense, at least right now, to say, all right, it's somebody else's problem. I don't want to have to worry about these things.
Mm-hmm. But what about the costs, right? So convenience is there. I love that, right? So what about the costs? How do you keep the costs in check? I mean, what should an enterprise be worried about when they're using a GPU cloud?
Yeah, I mean, at the end of the day, you have to balance it. How much, because cost is not just, what is your bill going to look like for a cloud, right? For your cloud computing at the end of the day, because you might be comparing that. Okay, what is my bill going to look like for computing if I ran this on-prem? I don't think it's any different between GPUs and traditional cloud, right? This kind of cloud versus not cloud war has been going on for quite a long time now. And so it is really just like, where are you in your journey, right? In how mature are your development teams, your infrastructure teams, or do you even have these things? Because if you don't, you're in for a world of hurt if you want to say, okay, I'm going to do all of these things on my own from scratch. Because it's not just now, how much is it going to cost you to buy the servers? How much is it going to cost you to co-locate the servers? It's going to be, how many people do I have to pay? And can I even find the right people to manage these things? And when they inevitably go down, right, how much am I going to pay? Because now my one of the things that's maybe central to my business is now also down, right? So it's also in terms of like, the personnel, the risk, right? And I think there are very few companies out there that honestly can be very successful to be able to run these things on their own. It takes a lot.
So you're basically saying, I mean, this is the cost actually is not only about the infrastructure. There's also, really the talent that you have, hiring those people and retaining those people and all of that, right? So I mean, there is substantial cost that is involved. So let me actually, we have a few questions. So let me actually take a few questions. So David has this question: any thoughts on the expansion of storage relative to large language models, etc., and the future of how that will grow? Will it grow in parallel to the advance in demand of GPUs? So it's basically compute is growing. What do you think about how the storage which direction will storage go? I mean, of course, it will increase, but any thoughts on that?
Yeah, that's actually a really insightful question, because when most people think of GPUs and LLMs, the last thing they think about is the storage, although storage is actually one of the most important things. Because what I've been telling people is, when you think of, how is a AI ML workload and, things that use GPUs different than a traditional CPU workload, it's not just that you're using a GPU as your accelerator, it's that you actually have a ton more baggage to carry around. That baggage is manifest in not just the dependencies, right? The code generally is not very large, but the dependencies are. You're not carrying around, entire kernels. PyTorch is like multiple gigabytes now for the install. And then also, if you're talking about these large language models, they're big. And so storage is now very important, right? Because not only do you have to figure out, okay, if I'm going to train this thing or fine tune this thing, where do I store these things? And how do I get them to my accelerators fast enough? But then also on the inference side, how do I make sure that the things load into, for example, VRAM? How do they swap in and out of VRAM to system RAM or even to disk to accommodate larger context sizes, for example, right? So all of these things are absolutely important to building out something that is going to be able to serve these workloads in a robust way in the next several years. So what I've seen out there is that there are several companies that are aiming to tackle these solutions. Some of them are a combination of hardware and software companies. Some of them are trying to do it with software only, with commodity hardware. And there's kind of like a battle raging on like kind of who's going to win, right? So one of the companies is like Vast Data. There, you might have seen in the news that they've got some contracts with some of the bigger players out there. They are a hardware software solution that is going to offer storage at multiple different layers, but it's backed by very fast NVMe storage. So that's really exciting because that will allow us to do more in terms of abstracting away, right, all of the things that no one really wants to worry about in order to run these workloads. So kind of to recap, like storage is going to be incredibly important. Where we're going to end up, my kind of vision of a nirvana would be, hey, we can ideally have a network is a part of this, right? So it's really storage that's attached via really, really fast networking, so that at the end of the day, we can kind of treat this cloud as more of a disaggregated solution rather than right now having to treat it as, okay, I have a node here and a node here and a node here. Like, how do I string these together to make sure that they can talk fast enough and do what I need them to do? But the dream is really to be able to say, okay, I can just have like something that acts like one big supercomputer, right? That's a monolith. It has its own storage. I don't have to worry about what it's connected to or how it's connected. It's got like one giant VRAM construct. So I don't have to worry about, okay, is it here? Is it here? And I feel that's what NVIDIA is trying to build with their kind of superpod architecture. I think we're very early in this, but that looks like to be where we're kind of headed for the larger scale workloads that we're seeing.
Yeah, that's great. And there is a product specific question. So Craig has this question about how's RunPod different from NVIDIA Cloud GPU solutions?
Yeah, one thing that we have adopted at RunPod is this idea that there are so many people, businesses, enterprises that are going to need to run these things. However, right now, if you really want to run things well, you're going to have to dig really deep into many different parts of the software stack. And you're going to start by saying, holy crap, there's a lot here. Where do I even get started to deploy something in production? So RunPod's current thesis is we want to make a platform that makes it dead simple, right? To be able to not only deploy something to production, but to be able to deploy something to production that's actually worth deploying. What we've seen is that there are solutions that go very extreme in either direction, where you can deploy anything you want and you can build something very special, but you better know really what you're doing, right? And the best example is just if you get a custom bare metal deployment from somebody, right? It is really, hey, here's a really expensive computer. I really hope you know how to use it, because if you don't, it's not going to be very useful for you. And then on the other extreme, you've got platforms that are like, hey, we're going to make it really dead simple for you to deploy this thing. But a lot of the feedback that we've gotten is that, hey, I can deploy this thing in a couple minutes, but then like it's not worth using, right? It's not worth me building my business around this because it's just too vanilla. So RunPod is all about how do we make it easy to deploy something, but actually make that something that you're deploying both customizable enough for it to be worth something and performant enough for it to be worth something.
Okay, that's great. So let me expand on this a little bit, right? So as you may be aware, we used RunPod for our fine-tuning module in our large language models bootcamp. And what I noticed was that it was relatively easy to get, I believe we used Llama 2 7 billion parameters for 4-bit quantized model. Fairly straightforward. You just load it up, you just click, the image comes up with that model, and then you go and just modify it. So give me an idea, right? So if I wanted to do something like this on my own, what would that entail? And what is it that RunPod is really, maybe, or you could tell me the other way, right? So what does it entail end to end when you create an instance or an image like this? Like what kind of process is involved and why it makes sense to actually go and use the GPU cloud?
Yeah, absolutely. Let me preface this with, that experience is kind of the MVP product that we created. And one thing that we're actually doubling down on is the other part of the platform, which is more around production serverless inference, right? So that's really, more for when you want to deploy something into production versus the product that you have used is more around how do I get you access to something that is less abstracted, but has batteries included. But to answer your question, it really is the whole like, hey, how do I get away from needing to be a Linux admin in order for me to actually do my experiments, right? So in this case, what I've heard from a lot of people that have successfully run fine tunings on RunPod, for example, is like, okay, so I looked up tutorials because I know what I want to get done. I know somebody's probably already done this. Okay, I'm gonna go look up a tutorial, a video tutorial, and follow it. That's what a lot of people do when they're trying to run these workloads. And they said, hey, I really appreciate RunPod because I could skip the first 25 minutes of this tutorial. Because the first 25 minutes of this tutorial was literally like, okay, now I have a VM. How do I install, the many dependencies that I need to install and wrangle this crazy dependency matrix and figure out like what breaks what. And then after I installed the latest version and found out that it broke this other version of this other library that I used, like how do I troubleshoot that? And so it saves a ton of time because we've already done the things that you would have maybe had to wrestle with, if you were just going to do this from scratch, right? So it really is kind of this batteries included, you don't have to be a Linux admin in order to run a fine-tuning experiment kind of experience that a lot of people are appreciating.
Okay. And what about inference? I mean, can we use the same part for inference as well? And I'm talking about inference, deploying this inference service, right? So not really doing inference locally, but deploying that as a web service. Do you offer that at the moment?
Yeah, so that's more on what our serverless product does. That allows you to deploy your own private endpoint. It has scaled zero functionality. We have our own auto scalers, queues, load balancing. Everything's kind of included there. So that is something that we are actually actively in development to make even better. Right now, it is very open. And what we're finding is a lot of our more successful users have the capability to kind of figure out what they should be doing, but they're all kind of running through the same types of experiments. They're like, okay, well, what kind of serving layer do I pick, right? Do I make this software choice or this other software choice? And as we're kind of working with them, we're like, hey, you guys are actually all doing, you guys are all trying to reinvent the wheel, right? And you're arriving at the same common conclusions. And what that tells me is that we should just be doing better at saying, hey, this is probably the way you should be doing it to begin with. It'll save you a ton of time. So to answer your question, we do have that as a product. And what we're focusing on right now is how do we make that more efficient, both from a functionality standpoint and also from a user experience standpoint, so that we can reduce the amount of friction required to go to production.
Okay. That's great. So I will switch again to some questions that have popped up. I will try to. I don't understand all the questions completely, so I will just read them out, and then maybe we can answer. So Shweta has this question: on a hardware level, are the NVIDIA GPUs only the ones that are good enough to be used for training AI models? So that's the first part of the question. And then the second part, if I understood correctly, like a long question, but can we estimate ahead of time how many GPUs would be needed for a specific AI workload? I'm paraphrasing it.
Yeah, excellent. So I'll address the first. So no, you can definitely run these experiments on other types of accelerators, right? Like Raja said, I mean, if you really wanted to try doing it on CPU, you can do it on a CPU. It's just going to take a really long time. So you can use things that are not NVIDIA GPUs. The reason NVIDIA is on top right now is because they have very good synergy between their hardware and software. Namely, it's CUDA, right? CUDA is really the thing that's driving NVIDIA to the top. If you look at, for example, AMD GPUs, right, you can use ROCm as a bridge, right? You can run, for example, Stable Diffusion, right, on an AMD GPU. The reason it's not as prevalent is because people would much rather just use the thing that works, right? One of the common things you'll see is like, look, when you really are on the cutting edge of this stuff, the more things that just work, the better, right? Because you can then get on with your lives and actually make breakthroughs, right? You can do exciting things. So there are very few people that are interested in, it's like, okay, let me debug this random stuff that only happens when I use this other type of accelerator, right? There's a lot of debt that you take on because you have to put in the effort to like troubleshoot all of these things that come up because you're in the minority, right? So no, you can use other type of hardware. It's just NVIDIA GPUs are the easiest way to get started, right? And it has the most support. That may change, right, in the future. There's a lot of incentive, right, to be able to use other types of hardware, especially because NVIDIA GPUs are not cheap and they're not plentiful right now because larger corporations are kind of hogging the supply. So that's it, right? So if you really need to save money or whatever, and you're okay to put in the sweat equity, you can use a different type of accelerator. In this case, maybe AMD is a good choice. But if you just want the hardware to kind of get out of the way as much as possible, it's not like NVIDIA GPUs are that easy to use already, right? So that's number one. And then number two, I believe, was just about how do you kind of scale this stuff as far as how do you size what kind of instances you need. And the unfortunate truth is that there's no silver bullet to this. One of the things I actually had a conversation with my team about yesterday was how can we better help our users, right, size these types of workloads. If you are training a foundational model, you better be willing to spend quite a lot of money to train it, right? So if you're going to be training something from scratch, then you're looking at, at least tens, if not hundreds of thousands of dollars, even the millions of dollars, right? If you're going to be training a model like Llama 2, for example, and you're looking at thousands of GPUs or tens of thousands of GPUs to train a foundational model. It really depends on how big it is and how much data you have. But if you want it to be good, right, you're looking to spend a lot of money. A lot more people are going to get better results by fine-tuning. And so when you're looking at fine-tuning a model, now your compute requirements are much less. The fine-tuning of a model is really going to depend on what kind of fine-tuning you want to do, whether it's a full fine-tune, where you relax all parameters and you allow fine-tuning on all parameters, or you want to use something that's more parameter efficient, like a LoRa you might have heard of. And if you're going to use that, then it requires less compute. So to give you a ballpark, right, if you want to do a full fine-tune, let's say on like a 7 dB model, right, you're looking at several A100 8X nodes, right? So that's not going to be cheap already. If you want to do a LoRa fine-tune, right, you might actually be able to get away with fitting it on a single GPU. And then depending on, how big your data set is, how your hyperparameters look like, right, that can then, again, kind of skew you in either direction as far as do you need more GPU or less GPU. I've seen some pretty decent fine tunes come out of like a single 4090. However, evaluating these models is not easy in and of itself. So what I'm thinking is if you are really interested in getting like a good fine tune out, you're realistically looking to run multiple experiments. And it's going to take you a while because you're going to need to get a bunch of results out of this. And then most likely you will have to qualitatively test them to really get the best results. So I hope that kind of answered your question. At the end of the day, it's like, it's not easy, right, to evaluate. You or somebody else will need to run experiments to empirically like test out like what's going to work the best. And that's actually something that RunPod is very interested in doing. For the most popular types of fine-tuning that we're seeing, we would like to both run these experiments and aggregate those results so that we can at least give decent recommendations of, oh, you're doing this, and we've done this before, and so here's what you might be looking at as a start, right? And if you want to customize things above that, well, you may need to do a little bit more of experimentation.
And so in your case, in RunPod's case, do you size it to the minimum that is needed? So do you provide any guidance? So you could have, let's say I'm instruction fine-tuning Llama to 7 or 70B, whatever that could be, like with LoRa and quantization, like QLoRa, right? So now that I'm doing it, there's no sizing of the instance requirement, because GPUs actually they get expensive very quickly, right? So, so do you provide any guidelines, or does any provider, for that matter, any GPU cloud, do they provide any guidelines on sizing of the instance?
Yeah, so right now we do not. However, it is on our near-term roadmap to incrementally provide better guidance around this. So we will be launching a fine-tuning service that will both provide guidance around what hyperparameters and what hardware to use, and then also say, okay, well, if you want it to go faster, right, you can size up. But I think the most aggravating thing for users is around sizing is not whether I can get it to be faster or slower. It's whether it's going to work at all, right? So really that minimum sizing is very important, because we have already, we've run experiments where we're like, oh, with these hyperparameters, crap, it ran for a while and then ran out of memory. Okay, we got to tune the hyperparameter. Okay, I got to run it again. Okay, crap, it ran out of memory somewhere else. Okay, what do we need to change? And this is just a waste of time and compute. So if we can provide good guidance around, hey, you probably need at least this, and if you want it to go faster, you can size up, it's going to save a lot of people both time and money.
Okay, that is great. So I will bring in a question from the audience. So Ivy has a question. Do you use VPU by Intel? Of course you don't, but do you, can you mention, VPU, I don't know, I've never used it, but VPU by Intel?
No, I haven't, we haven't built this or, done anything with that. RunPod is currently exclusively NVIDIA GPUs because we've just seen that most people want to use NVIDIA GPUs. That's not to say that we will be NVIDIA exclusive forever, but it just makes the most sense right now.
Okay. That's great. So there is another question. I don't quite understand it, so I will just mention and we'll figure it out. So Hai Long has a question. What will succeed in GPUs in the future? Will it be ASICs or another form of specialized computing architecture designed specifically for machine learning? I believe GPUs are becoming more specialized for machine learning as we speak, but Zen, I will let you expand on this.
Yeah, it's actually something I'm really excited about. So RunPod was accepted to AI Grant Batch 2, so I was at the AI Grant Summit. One of our cohort is actually designing a chip that's specifically for LLMs. And there are other startups out there, they're actually fairly plentiful, that are very interested in designing chips that are specifically geared towards a very focused, right, skill set. And so I had a couple of these conversations, and really the bottom line is that GPUs are really expensive to make, and then also really expensive to buy, and the R&D required is a lot, right? So if you can just cut pieces, right, off of the chip design that are not needed for a specific type of workload, then the idea is, as long as that workload is prevalent enough and there's enough usage for it, then you can make a chip that is, if not performant, at least cheaper, right, than its general counterpart. Because right now GPUs are a general purpose computing unit. However, if you're just like, okay, well, I know that transformer LLMs require this specific type of matrix math, can we build a chip that is just really good at that, right, and sucks at everything else, right? It can't run games. That's exciting, because then we can actually cut down the cost, because GPUs are incredibly expensive to buy and run right now. And so I'm really excited to see what kind of the next generation will bring. The challenge is going to be, how can we have not only the hardware to support this, but the software, right? The software is incredibly important, because it doesn't matter if you've got this wicked fast hardware. If you don't have anybody writing software for it, it's not going to catch on. So that's something that I'm really looking forward to seeing in the next couple of years. The unfortunate thing is, designing and producing a chip is a really slow process, right? It's not like I just write some new software and I can test it. There needs to be a ton of R&D in simulations that goes into before you even fabricate your first physical chip, and then it costs an insane amount of money to just even fabricate, right? So it's probably not going to be, at least for several years, but I'm really excited to see what people come up with.
And where do you think most mistakes or most, I would say, what are the best practices in terms of efficiency, in terms of cost, in terms of desired outcome? What is the best way to use a GPU cloud? Let's say I'm the CIO. I'm the person who's actually responsible for the budgets in my enterprise. What kind of education and learning and development should I have for my developers who are going to be using this GPU cloud? So where do people lose money? Where is the lack of efficiency? What would you recommend? It is almost like you're giving away how you make money, right? So I mean, because you make money, if people started using GPU clouds and in general cloud computing efficiently, the margins are razor thin, right? So yeah, but I will let you answer. So this was on a lighter note. Yeah.
Yeah, that's it's interesting. I feel like a lot of people would probably gravitate more towards the technical for this, but I would say that you start more on the business side, right? And your business model. And so if the question is, how do I make money off of this? If you're looking to drive your margins based on like really creative technical solutions when it comes to GPUs, that is probably fine as long as you understand kind of where you are today versus what is in the realm of reality. But what's going to probably hamstring you more than that is if you got this idea that I'm going to get a bunch of users and burn money and just grow, right? And then I'll figure that stuff out later. I think that's where a lot of people are going to run into issues. Where we're seeing, like, even if you look at, the big providers, right? I don't know how much money OpenAI burns on compute. I don't know how much like Azure and Bing, right, burns on compute. I'm sure it's some astronomical number. And so I'm sure that they probably have a plan, right, of like, how do we eventually make money off of this? I don't imagine they're making money at this point, right? They have probably a lot of revenue, but one of the things actually I saw an article about the other day was this idea that GPU compute is not cheap, and a lot of people are charging what amounts to a flat subscription model, right, for usage, rather than paying for the actual usage. And like this kind of model, unless you're really good at running projections, and I'm not sure if anybody's really that good at running these projections, right, is probably going to get you into hot water no matter how well you're going to be able to optimize from a technical level. But at the end of the day, it really comes down to how can you best fit your workload into the discrete types of GPUs that you're using right now? How do you batch things intelligently? And how do you not incur switching costs? Like, for example, specifically switching things in and out of VRAM when you don't need to be, right? And these all have like creative solutions, but they're definitely not solved problems. And so, what it comes down to is like, look, the larger your scale is, probably the better off you are, as long as your business model is sound. And I believe that as, in the next few years, GPUs really are going to become more mature in terms of the cloud software stack, and will move more towards kind of like how CPUs have evolved over time, better virtualization, better sharing of resources, so that these types of considerations will get easier, right, for users to make over time.
Okay, that's great. So the solutions that you gave me, they seem a bit too technical, right? So, and I'm the CIO. I'm not the most technical guy at the company, right? So I'm sorry, and like I have to take that jab, right? So I'm not the most technical guy, right? So in general, what are how would you go? How should I go about actually bringing? Let's say if I want to sign a contract with the RunPod or maybe NVIDIA or some other provider. What should be the considerations from strictly from a business or maybe semi-technical, not too deeply technical, right? So whether there's going to be swapping from in and out of the VRAM or not. I mean, not that much, but at a very high level. It's more of a business decision if I have to make. How should I do it?
Yeah, so I would be very interested in how long is this going to take me to get into market, right? Like, realistically, if I go with this solution, given my current, right, development chops, right, I have a development team or whatever, like, how long is it going to take them to ship this into production, right? Is it this week? Is it going to be a quarter? Right? Is it going to take a year? And then from the platform itself, like, does it qualitatively solve my use case? Because I've seen actually people that have started with a solution and they're like, oh, wait, this is just not going to work. Like, qualitatively, it's not going to work. So if it's not fast enough to solve your problem, or if it's not good enough in terms of the output to solve your problem, then I mean, that's just a no-go, right? It doesn't matter what else. And then it's really, okay, well, I can get it to production quickly. It qualitatively solves my problem. And then the last thing is, okay, well, how much is this really going to cost me? Like, does it make sense from a business perspective? Like, am I actually going to make money off of this? Am I okay burning money, right? And what does my time frame look like in terms of being able to optimize this? Does this platform, if I'm really looking at signing a year agreement, does this platform lock me in to basically a situation where I'm never going to be able to make money, right? And if that's the case, then what am I thinking of doing after this this runs out? So I believe that there is a strategy where you can say, okay, I'm just going to pick something that works, that'll get me to market, and I'm just going to burn money for the foreseeable future. And then I have a plan to like optimize. That's fine. But there needs to be like a conscious choice to do something like that, right? Because otherwise you're just going to get into trouble.
So I will take one more question from here. Madeline, looks like that you know how data centers and the costs and everything, right? So what do you see becoming the average kilowatt per hour can a data center running? Yeah, workloads, right? So I don't know if, I don't know, Zen, do you have any idea? I don't even know how much.
I'm not going to be
right, so,
the best person to answer this question, but I will provide like some high level insight on this, right? So the interesting thing about data centers that run GPUs is that they end up, most of them, unless you're running like immersion cooling or something, they're actually going to be very sparse in terms of racks. So if you look at like a traditional data center, the direction it's gone is like, how do we get just this stuff like the most dense as possible, right? I want to cram as many servers into racks and then as many racks onto the floor as I can fit, because physical space is actually at a premium. With GPU servers, it's actually the power and the cooling that's the limiting factor. So if you go to a traditional, if you can think of it as traditional, if you go to most GPU data centers, they're going to be really empty. It's going to be mostly empty space with a few racks in there that are going to be running GPU servers, because it's not that they can't fit them in there, it's because they don't have enough power or they can't cool them. And so the kind of the exception to that is if you have immersion cooling, it becomes a little bit easier, but even then power density is an issue. So I don't necessarily think that, looking at average kilowatt per rack necessarily makes much sense, but more like maybe the average kilowatt or gigawatt or even higher that a facility is going to have to run, and then like what's the footprint of that facility, and how many of said facilities can realistically even an entire city's power grid support, right? Because we're actually going to be quickly running into kind of infrastructure issues where these giant data centers actually take more power than the cities next to them, right?
Okay. So, coming back to my question, right? So based on the RunPod, the customers from RunPod, what kind of workloads are typical? I mean, do you see a lot of, do you see a spike in more of generative workloads, generative AI workloads? And what are some other interesting workloads that you don't know, right? So, or what kind of workloads do you see from your customers?
Yeah. So at least the customers that we talk to, right, on a daily or weekly basis, the vast majority of them are running generative AI. It just makes a lot of sense, right? There's just so much practical application, right, that can be done in many, many different business areas. Of that, probably a good half of it is going to be generative images or video. Video is getting really, really popular because, let's face it, people are very interested in this idea that you can just ask, right, the AI to generate you something that moves. And you get these really amazing aesthetics and creative qualities, right? So we have a lot of companies that are kind of trying to create more in terms of like experiences, right, for people, which is really exciting. And then the other half of it is really around text, right, generation. LLMs obviously have many, many different applications. So that's pretty cool. I personally am really enjoying companies that are doing generative audio. There aren't that many companies that are doing this, but I'm seeing it kind of grow as a use case. And that kind of workload, it just really speaks to me. I like music, and I think that I have had my stints, when I was younger, like of playing instruments and things like that, but I generally have lacked the patience to really become a master at anything. But this idea that I can generate music that's custom to me, that is really to my tastes, is very appealing to me. And then also this idea that communication is key, right, for the growth of our society. And like, for example, there's one startup that's doing this real-time changing of accents or elimination of accents. And I feel like the better we can make communication between people, like the better off we are as a society. And so these kinds of use cases really resonate with me. And I really would love them to be successful.
Yeah, that's great. So we are almost at the hour boundary. So what's the most exciting thing that is coming up on your side? So, or maybe in industry, maybe, in general, in the industry, what is the new, what is up and hot and upcoming, and what is hot and upcoming at RunPod?
Yeah, one thing that I'm very interested in is the continued success that people are seeing building off of these open source LLMs. Like Llama 2 is, I set the world on fire, right? And Llama before it. And what I'm really interested in is how we can continue to kind of fuel that to get better results, right? OpenAI currently with GPT-4 has some amazing things, right, that it can do that honestly nobody else can really compete with. But I feel that open source can compete. And from a RunPod perspective, I really want to empower the individuals and groups of individuals that are really on the front lines here and pioneering all of the new innovations that are going into open source development. So seeing what people can do in terms of pushing the envelope for Llama 2 fine-tunes, and then perhaps actually aggregating that into a larger hierarchy, whether that's MOE or some other type of architecture, to build something that can compete, right, on the same playing field with something like OpenAI's offering is very exciting to me. And then also just seeing what people are using these things on a more niche level, right? Just looking at all of these use cases that I never even knew existed, right? One of the things that somebody said about OpenAI was like, OpenAI is one of those startups that's weird because they just built a product and then people are like, oh, I can use this product to solve this random problem that no one's ever heard of, right? Startups generally don't operate like that, right? They find a problem and they solve the problem. They don't, create a solution and then other people find problems that, the solution goes to. But really it's like, how can we empower this motion, right? Of open source, of people creating things that they can share with others and solve these problems. That's not going to be this, centralized solution that is going to be controlled by one entity.
So is Llama 2 the most popular one out there among open source models? So I heard you. Okay.
It's Llama 2 by far. Mistral's got some pretty awesome press behind it right now. I haven't gotten a chance to play around with it, but I've heard good things. But I'm really interested, right, in kind of these smaller, very capable models that enterprises can run, right, either on the cloud or on-prem to solve specific use cases, and then how we can use those perhaps as building blocks to build something greater.
And do you plan to just continue to give the vanilla base models, or just maybe some augmentation to the model, maybe fine-tune models, and you can build on top of that? I'm just curious, out of curiosity.
Yeah, no, we're interested in building this entire ecosystem out. So basically, all of these things that we've talked about are in the pipeline. Okay,
that sounds good. So I think we are right at the hour boundary. Zen, absolutely enjoyed talking to you. Thank you for your time.